Good morning. Myself, Prabhakaran J, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is state variables and state model from the subject is linear control systems. Let us discuss. In modern engineering, systems are becoming more intelligent and more complex. To control these systems effectively, engineers need advanced mathematical methods. One of the important method is state variables analysis. In this presentation, we will understand what state variables are, what a state model is, why they are important, and how they are applied in real engineering systems. Now let us move to the first slide. Today's control system are used in robotics, aerospace, automobiles, and power plants. These systems operate in changing environments, so they must be adaptable and reliable. Traditional control methods sometimes fail when unexpected condition error. So engineer started asking an important questions. How can we design systems that are not only functional but also intelligent and resilient? This challenge lead to the development of modern control techniques like state variable analysis. Now, let us discuss the first pillar of design thinking called empathize. In design thinking, empathize means understanding the user needs. Um, but in control system, the user is not only human operator, it also includes the system itself and the surrounding environment. Engineers identify important state variables such as temperature, pressure, speed, position, and voltage. These variables describe the internal condition of the system. By understanding these variables clearly, engineers can design better and safer control systems. So the main idea here is understanding the system deeply is the first step toward effective control design. The second pillar is define. Here, engineers clearly define the problem. In control systems, this means defining the desired behavior, specifying operating limits, and identifying system requirements. A system model mathematically represents the behavior of the system and its state transitions. It gives a clear mathematical description of how the system changes with time. This helps engineers analyze and control the system more effectively. And third pillar is ideate. In this stage, engineers generate different control strategies. They study how state variable interact with each other and how the system responds to inputs. Based on this analysis, engineers develop suitable controllers. Some common control technique like PID control, state feedback control, and observers. Different approaches are tested to find the best solution of system performance and stability. And the fourth pillar is prototype. Before implementing the actual systems, engineers create mathematical models and simulation. The state space representation acts as a prototype model. Using this model, engineers can simulate the system behavior, test control algorithms, and predict the system response. This reduces errors and improves reliability before real world implementation. Prototype testing also saves the both time and cost. Now we have a small classroom activity. The puzzle question is you can see on your screen. Your job is you have to find the value of the question mark position. And fifth pillar is test. After developing the model and controller, engineers test the system performance. Different input and disturbances are applied to the system. Then the actual response is compared with the predictable response from the state model. If any error or instability occurs, the control laws are refined and tested again. This continuous testing process improves accuracy, stability, and overall system performance. This slide explains the integration of design thinking with state variable analysis. The process includes five important stages, empathize, define, ideate, prototype, and test. Together, these stages form a complete engineering framework. This framework helps engineers create intelligent, adaptable, and efficient control systems. And now let us see real world applications. This case study is about advanced nuclear reactor control. The main challenge is maintain safe and flexible operation under changing load conditions. Engineers identify critical state variables related to charging, discharging, and load following operations. Using a state model, engineers can predict system behavior during disturbances. PI regulators and reference governors helps maintain safe state transitions. This example shows how practical importance of state variable analysis in critical systems. Now we are in the assessment quiz part. Let us check your understanding through this assessment quiz. Here we have two assessment quiz. First one is what is state variable? Option A is external disturbance applied to the system. Option B is variable that describes the internal condition of a system. And option C is output signal only. Option D is constant parameter of the system. Which one is correct? Option B is correct. And second question is which representation is commonly used in model control system? Option A is block diagram representation and B is a transfer function representation. Option C is a state space representation. Option D is Boolean representation. Which one is correct? Yeah, option C is correct. That is a state space representation. The state variables describe the internal conditions of a system. State models mathematically represent system behavior. These concepts help to engineers analyze, design, and control model dynamic systems effectively. By integrating design thinking and state variable analysis, engineers can create smarter and more resilient systems for the future. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.